are more than welcome to come down and ask the reactor supervisor, Adam Malakote, for a tour, because we're open to tours throughout the campus for anybody that wants to see it. In fact, we've started a reactor operator training course, which is preferentially towards nuclear engineering majors, but truthfully we would choose, or we would allow a mechanical or an electrical or whatever if they were interested in getting an NRC operator's license, just to have something extra on their resume. So it's a great teaching tool. Okay, I'm going to go through the introductions here. We're going to do it up here or down here first and then pass it on to Idaho Falls to ease the mic transition. So introduce Dr. Jason Harris, who's right here on my left. And then you can
Hopefully. Okay, good morning. As Dr. Engr said, my name is Dr. Jason Harris. I'm maybe somewhat of an oddball in the group. I'm a joint appointee in both nuclear engineering as well as physics. Let me just give my information as well, and then I will talk a little bit about my background and what I do. So again, I'm Jason Harris. My office is over in physics, so the physical sciences building 123E, which is again on the main floor. If you come into the building, you walk down the steps. My office number is the 282-3364. And for now, I don't know how we're going to be affected with the new Google apps that the email is going over, but physics has a separate server, so I'm at harris@physics.isu.edu. So again, I'm a joint appointee. Actually, Dr. Engr is also a joint appointee, technically with physics. My background is mainly in the area of health physics. Health physics, if you're not familiar with that field, is the discipline, I guess, that involves protecting people and the environment from the detrimental effects of radiation while trying to, I guess, advertise or use the beneficial effects of radiation. So in a lot of places, nuclear engineering and health physics go hand in hand. Here at ISU, it's a little bit different because health physics is in the physics program, but a lot of other major programs around the country, if you go to University of Michigan, for instance, Florida, several of those, health physics is actually in a nuclear engineering department. So my background's in health physics, although I do have a nuclear engineering background or degree as well. So I deal mainly with reactor health physics, so looking at protecting people and occupational workers in power plants and other areas that deal with radiation, again, from the harmful effects of radiation. I also do some other work or some other non-traditional areas of nuclear engineering, such as looking at isotope production, and then also doing some homeland security work or research as well, utilizing radiation and methods of radiation physics for detection of materials. So that's, I guess, pretty much my background. But I probably will be teaching some classes in nuclear engineering. I've only been here a couple years now, and the joint appointment is just over a year old, but I hope to see a lot of you around in nuclear engineering. So, and then I'll introduce, I guess, our third faculty member here, Dr. Jay Coons, who's a little bit older than myself and been here a little bit longer. But
when it comes to age, I guess I win. Age comes with them. Okay, where's the Zoom? There's no Zoom on there.
Oh, this one doesn't have control.
No controls here. Operator, maybe zoom in a little bit on that. I hope you can read that. I'm right across the hall from Dr. Engr. In fact, if we're going to have private conversation, we have to close our doors because we can hear each other very easily. Just to give you my background, I started out in physics like I think most of us did, didn't we? And my degree was from Carnegie Mellon, where I was looking at what goes on subparticle-wise in the nucleus, what holds it together, mesons and how they scatter. And about that time, nuclear power was just coming into its own. And it looked like that was really the way to go, because when you look at the numbers, there's a factor of 1 million. You know, some of you probably think, why is nuclear so important? Excuse me. Maybe it's 10 times better than fossil as far as the energy you get out of it per unit mass. No, it's not 10 times. It's not 100. It's in the millions. And that just seemed like the way to go. So ever since I got out of school, I've been in nuclear engineering. Started out working at INL, spent 20 years there. The last 5 of those was in geothermal energy. Now I know you folks in this class are you're interested in all disciplines. Some of you are going into mechanical, some civil, some electrical, some nuclear, and I guess maybe some of you even computer science. Okay? Well, just to let you know, I'm a licensed professional engineer. It's not in nuclear, it's in mechanical. And I spent 10 years of my career in geothermal, which has nothing to do with nuclear. And in addition, going along with health physics, we have a close association with the Department of Physics, very close association. And I'm what's called a certified health physicist. It's abbreviated CHP. My son says, what's that stand for? California Highway Patrol? I said, no. Nothing to do with that. Okay. So that's my background. And just to tell you why I got into geothermal energy, it was back in the days when we used to have the Atomic Energy Commission, and it was split in the 1970s by Congress. Congress said, Atomic Energy Commission, you cannot both regulate and promote nuclear energy. We have to have 2 separate organizations. One we'll call the Nuclear Regulatory Commission. They will be the policemen who will watch over what's going on with reactors, because obviously reactors do represent a little bit of a hazard, just like coal plants do, because coal plants can have steam explosions. People are killed in coal plants all the time. In China, there are 5,000 to 7,000 people killed each year in coal mines. So other forms of power can be dangerous just as well, and there are regulatory agencies for those. The Nuclear Regulatory Commission regulates nuclear energy, and the Department of Energy promotes it. So there are those 2 organizations. And when that happened, nuclear plants were being built. 200 of them were planned in the United States. Only 104 ever got built. And it looked like nuclear was on its way. It was going to solve all the world's problems forever, and it can. But something happened between then and now. 3 Mile Island occurred. But more so than that, whenever 200 plants were being built, the Department of Energy said, we don't need research and development anymore. And that's very odd, because we always need that. But at the time, I was at the Idaho National Laboratory. It wasn't called that at that time. And I had 50 reactor physicists working for me. Suddenly, I didn't have any work for most of them. So I had to look at some other ways of keeping them busy so they could earn a living. And I took a look around at Idaho, and I thought, there's heat in the ground. There's Yellowstone Park up there. All sorts of heat underground. Maybe Idaho should look at geothermal energy. And so I pointed a part of INL's workforce in the direction of doing geothermal energy, which is nothing to do with nuclear. You can call it mechanical engineering and geological engineering and geosciences. And what we did at INL at that time is we started the Raft River program and drilled 5 deep wells and got energy out of those. And then we drilled some wells in Boise and got geothermal water out of those. And now those wells and some others are heating all the Capitol buildings in downtown Boise. Excuse me. So that's a little bit about my background. I'm anxious to see all of you go into engineering. There's a lot of excitement. We're here to promote nuclear engineering because it's our feeling that nuclear is the way to go for future energy. It doesn't emit greenhouse gases, and what comes out of nuclear power plants for electricity now is the cheapest power that we have, except for hydroelectric power. It really is the cheapest because most of our nuclear plants have been built a long time ago and they're already paid for. And the fuel for nuclear power plants is dirt cheap. It costs some money, but it's about 1/10 the cost of the power that you use in your home. So with that background, we're excited to talk to all of you. Nuclear is interdisciplinary. We need mechanical engineers. We need electrical engineers, well-trained electrical engineers in nuclear, and also civil engineers, because these plants have to be sited in places where the earth isn't going to split apart with an earthquake. You know, we don't want that to happen below a nuclear power plant. So thank you for that background. I guess it's time to turn it over to Idaho Falls.
Well, I'm not going to turn complete control over to Idaho Falls, but I'm going to let them introduce themselves. Okay, there's three of you up there. Whoever's closest to the mic, pick it up and we'll transfer control to you.
All right, is this mic on? Can you hear me? Or do I need to flap my arms? All right, my name's Todd Gonzaghi. I've been with ISU for about a dozen years now. You write that down. Some of you know me because I've sat through the lectures up here. My phone number is a little different. I'm actually over in the K's building in room 256. My phone number is 533-8113. Email just as you'd suppose. So hopefully you can read that. I was told in high school that I wrote with a lisp, and I've never really got over that. So I'm also a registered professional engineer in mechanical, kind of a jack of all trades. I started my education doing mechanical engineering. Then I did a master's degree in nuclear engineering, and then I did lots of PhD work, but never finished the PhD in turbulent combustion, numerical simulations. So I've got kind of a wide, diverse background. Back at the time when I took my education, there wasn't really any programs that offered nuclear engineering at a bachelor's level. It was all at the master's level. Unfortunately for me, the timing, when I graduated high school was 1979, which was the year of 3 Mile Island. So by the time I got myself educated and got into this field, the field was collapsing, or had already collapsed. I'm sure none of you remember that, but one of the reasons that was such a big event was just 12 days before the 3 Mile Island accident, in which nobody was hurt, there was no significant releases. It should have been a non-event. 12 days before that, Jane Fonda opened a movie called The China Syndrome. So this was on everybody's mind. There was lots of talk about the possibilities of a nuclear incident, and here it is. So, unfortunately, it was bad timing. One of the reasons why everybody here in this field is so enthusiastic is we've been waiting for a number of years for the resurgence. In the past, I've done quite a bit of research and looking around into alternative energies, and there really isn't any alternatives. There's none that I'm aware of that will scale to the point that they can really make a significant difference. Now, I'm all for wind and I'm all for solar, but they're just not really going to provide enough. So it's an exciting time. Hopefully have a chance to get to know all of you people quite a bit better. I'm also a licensed reactor operator down with the AGN reactor in Pocatello. So if anybody up here in Idaho Falls has questions about that, I'm happy to provide information. And I'd like to invite you all over to the K's building to take a look. It's part of ISU's campus. It's wide open. I'm happy to take you guys around, show you what's going on, talk about the research that's there and the research that's planned. So please feel free. You can wander over there and take a chance at finding me, or you can give me a ring on the telephone or shoot me an email, and we'll set up a time that we can meet and walk through the lab. Same thing goes for anybody in Pocatello. If you find yourselves up in the Idaho Falls area, please come by. And you will see me again in a couple of lectures, so I'll be back to talk to you some more. With that, I guess I'll introduce Dr. Michael Lineberry.
Thanks, Todd. We'll save the best for last in Dunsink-Gauger. I'm Michael Lineberry. I'm not going to write down my vitals because I'm pleased to be able to talk to you. I guess I'm the last lecturer of the nuclear engineering set. The lecture title I was offered by Professor Dunsink-Gauger is Story Time with Lineberry. Now, I'm not quite sure what I'm supposed to do with that. She told me to stay away from nuclear weapons, though, so we won't be going there. For those of you who are presently thinking about nuclear engineering, I congratulate you. That was very odd when Dr. Emmel asked for a show of hands and we saw a hand go up here on the screen. That's all we could see was a hand. It was something like out of Adam's family. You know. I noticed a couple of hands raised here. We'd like to talk more of you into nuclear for a very simple reason. A couple of my fellow faculty members ahead of me have mentioned. Nuclear enjoys a terrific advantage of being huge in its potential and what it can do for electricity supply in this country and the world. That's important to our economy. I'm a little bit of an odd duck in this crowd because I got an MBA from the University of Chicago late on in my second childhood. So I have a set of perspective sharpened by that. I spent over 30 years at Argonne National Laboratory. I was affiliated with both the University of Idaho and Idaho State University during that time, teaching classes here and there, reactor physics, reactor fuel cycle. And then in 2005, I left the lab, short stint at the Idaho National Lab, having rolled that over to Idaho National Lab from Argonne West. And since 2005, I've been full-time on faculty here. I'm a research professor of nuclear engineering, director of a thing we call the Institute of Nuclear Science and Engineering. The concern of that group is largely the research side of things, but all of us, whether we're in an institute or whether we're regular faculty in the college, all of us are part of the Department of Nuclear Engineering, and we all carry teaching responsibilities as well as responsibility to try to promote research. That research activity is important to you as students, even as undergraduates, because first of all, we'd like to increase the undergraduate research participation that we have. But secondly, Dr. Velas makes a good point, I think, that if you're not out there in the world of research, it's hard to stay current as a faculty member. And I think you'll find that we do about as well in the research end of things as any department, better than any department in the College of Engineering. I'm about to have a joint appointment with INL, but only for 20% of my time. Dr. Emmel is half-time, I believe. George, correct me if I'm wrong. Dr. Dunsink-Gauger, you're going to hear from next, is also has a half-time research appointment at INL. So we think that's an intrinsic advantage to the students because we bring to the classroom that sort of hands-on, state-of-the-art research view. Let's see, what else can I tell you? I spent half my career in reactor physics, fast reactor physics to be precise. That phase of nuclear engineering involves a lot of mathematics. Most of it involves a fair amount of computer science. If you're interested in that, reactor physics is not a bad way to go. The last half of my career I've spent in the nuclear fuel cycle, and the thing I enjoy about that is not the mathematical intensity. It isn't there. It's the diversity of the things that come to mind there. Taking care of the small but amount of, but nevertheless hazardous nuclear waste that we have to dispose of. You all read the newspapers. The nuclear waste repository that we have been angling for several years in the United States. Well, I don't know what I'd say. Is it dead or is it on life support? It's not in terribly good shape because the Obama administration is opposed to it. That was scheduled to go into Yucca Mountain, Nevada. Dr. Dunsink-Gauger and I have been down that hole. When it was put on hold, there was about $7 billion that having been spent on a hole in the ground, but more importantly, the characterization of it. But nuclear waste is only one aspect of the nuclear fuel cycle. Reprocessing and recycle of nuclear fuels, that too is a controversial subject, but the advantage of recycling nuclear fuels is you can use essentially all of the uranium resource, whereas in light water reactors today we use a tiny fraction of it. We use about 1% or slightly less of the uranium that we mine from the ground. When we recycle fuel, we can use essentially all of it. There are lots of other interesting aspects to the fuel cycle, which we'll touch on when you nuclear engineers are seniors, if not before. I don't know that I need to say anything else. Oh, yeah, I know. Any of you have any questions, want to talk about engineering or nuclear engineering, by all means stop by my office, or all of us will make this offer. I'm very informal. If the door's open, you're more than welcome to come in and introduce yourself. I'm on the second floor of the Tingey Administration Lava Rock building in the southwest corner, overlooking the river. It's a nice office. I'm supposed to be moving to K's, and yeah, I want to do that. I really want to do that, but hard to leave my office. Come by and I'll show you what I mean. With that, let me introduce Dr. Mary Lou Dunsink-Gauger, who will wrap up things from this end, Dr. Immel.
Thank you, Dr. Lambury. I think you probably picked up with his melodic tone what a good storyteller he's going to be. That was not accidental that he's the storyteller, and he's got lots of good ones to share. I will give you my information here in the Elmo. Dr. Coons may win the award for most wizened among us, but I win the award for the biggest name. Please don't feel obliged to say all of that. Dr. Gauger is just fine, okay? My phone number here on campus is 282-7809, and my email is my initials, mldg@isu.edu. I spend most of my time at my office here in Idaho Falls, which is next door in the lovely Lava Rock building. And I'm sort of like Dr. Immel with remembering room numbers. I think it's something like 335. But it's that general vicinity. I have also an office in Pocatello, which I visit when I'm there on campus to teach a course or attend a meeting or so on. So that must be one of the 235s. I don't know which letter it gets. Dr. Coons? Seems to know these things. All right, so anyway, there are my locations. As Dr. Lineberry mentioned, I have a joint appointment with Idaho National Lab, and I'm actually 50-50, so I do spend a good bit of my time working at the lab, and there are lab facilities just right in town that I'll be making use of, including the K's facility that Todd mentioned. So I'm sort of in and out, but as previously discussed, I think I am able to bring together a lot of opportunities, both university and national lab, because of that affiliation. We've been pretty good at finding positions for summer internships, for example, for students to work at the lab if that is of interest to you. And as Dr. Immel mentioned, we've got lots of good scholarship and fellowship opportunities, and I help out with some of those as well. My area of research is the back end of the fuel cycle, and that's sort of the phraseology that's used. The front end is the mining of uranium and making the fuel, putting into the reactor. The back end is when the fuel comes out of the reactor, and now what do you do with it? And it's not really a trivial exercise to consider how that spent fuel is handled, whether it's reprocessed or not, if it's reprocessed, in what way, and how do you stabilize the waste. So all those things are considered back end, and that's where I've focused my research. I teach the NE 402 class, which is Intro to Nuclear Engineering, which would be a course you take your junior year if you are a nuclear engineer major. But I'm available certainly to talk to any student in any major about nuclear. I do try to spend a lot of my time doing just that with public groups, going out to local schools and the local Lions Club, that sort of thing, and to teach them about nuclear. One other hat that I wear is faculty advisor of the student ISU American Nuclear Society group. I strongly encourage you, even if you're not interested in nuclear engineering, some of the activities that our student section participate in or sponsor are actually quite interesting and are open to all students, really. Is any of our officer group in Pocatello from the ANS?
I'm here, Dr. Gallagher.
Is that Bruce?
That's me.
Okay. Dr. Immel, would be okay if Bruce introduced himself really quickly, and then I'll relinquish the floor. I asked Bruce last minute, so he's a good sport. Last night, I kind of remembered I was supposed to ask the student ANS execs to come this morning, and I said, oops, I forgot to do that. So I sent a quick email, and so Bruce has come through. Bruce is a senior in Nuke, and he'll introduce himself, tell you about the ANS group, and then I'll be finished.
Okay, no problem. Give me the last 10 minutes, though. Okay?
Yeah, Dr. Gallagher gave me the early 10 o'clock email to show up here at 9 o'clock in the morning. So, I'm the president of the Idaho State University American Nuclear Society. My email is we have a meeting coming up. I believe it's October 14th at 6 o'clock here in the library in room B16 and room 208 in Idaho Falls. Yeah, can you switch to the Elmo?
Bruce, you're on the Elmo here in Idaho Falls.
Okay. We're planning to watch some of the footage from the SL1 accident out at the Idaho National Lab, and there's going to be free pizza there for anyone who's interested. So it'll be fun to come watch some interesting stuff and meet some of the seniors. For those of you who are a part of nuclear engineering and have a clue of what it's really about, you're ahead of me at least. So, because there's about 1,000 different directions you can go in nuclear engineering, and it's a very fascinating field, and there's a lot of work to be done. So, come to our meeting and come find out about the ANS. I'll hand it back to you.
Okay, Dr. Dunzik-Gugar.
I'm all set. Thanks.
We're over to you, George.
It's all yours.
Oh, okay. I'm sorry. I thought she was going to, I thought Dr. Gugar was going to finish up. All right. Oh, so you give me 15 minutes. Now I have to talk for 15 minutes. No problem. Okay. You all did Rube Goldberg exercises in mechanical engineering, correct? Yes, no? Ah, she didn't do that. Maybe
They skipped that.
Yeah, what?
They skipped it this semester.
Oh, probably because the class is so large. Okay, Rube Goldberg mechanisms, and you've all seen it, I think, are these intricate, complicated mouse traps, for example. You know, some way where you've got 14 levers and switches and ropes and cables to catch a mouse. And in mechanical engineering, in previous years, they've the professor there has had the students split into 3 groups or 3 teams of 3 each, 2 or 3 each, to come up with a Rube Goldberg, device, and actually build it. All right, that would, if you, I forget how it went. If you dropped a 1-liter bottle, that's your starting energy source, your potential energy of 1-liter bottle at 1 meter or something. I'm not sure where it was. That would then trigger a set of events that would then, I believe, place a bottle on a table, another liter full of water on a table. And so I thought, you know, it's not fair that mechanical engineers only get to do that. Why can't nuclear engineers? Because, you know, a 1-liter bottle of water can be amplified in a nuclear reactor in ways that you could never approach with simple cables and levers and pulleys. So I dreamed up, if I were going to build a Rube Goldberg device in nuclear engineering, it would look something like this. And of course, I was sketching this, like all great inventions, you know, just going along, making changes as I went. But the first thing I realized is that a nuclear reactor has more potential energy locked in it than any device we know, any other device available to us. There's just enormous potential energy locked in the nucleus available for fissioning. And so I figured, okay, nuclear reactors are controlled by control rods. That's what holds the reactivity at a nice shutdown level. But I can lift the control rod. And those that want to go to the SL1 accident will see one control rod. Well, I won't see it, but the effects of it, of one control rod being lifted out in an uncontrolled manner. But I'm going to do this knowing full well how far or how much I can pull out and get away with it. But so I pull this, I drop my liter bottle here, down, and it pulls the control rod out. The reactor goes supercritical, heats up in power, raises in power very, very fast. That's enough to push a ball, fairly heavy ball, you know, iron ball, if you will, out of the reactor, shoots out like a cannon. Now, because the reactor has so much potential, I can shoot this really high. I mean, you know, thousands and thousands of feet up in the air. So by the time it's ready to drop again, of course, the Earth has moved, and the ball is rotating around with it. And so the ball is going to come down in a slightly different place instead of just falling back into the hole. So this is all carefully calculated, you know, no-win situations. So it hits this point right here. Right? All the energy now of this potential energy of this heavy ball is falling down onto this thing. Well, because I have so much potential energy here, and all I have to do is lift a 1-liter bottle of water, I can actually run a little turbine. As this comes down, it pushes, I run a little turbine, and I can get a little electric light to light my project if I want to. You can't do this with mechanical engineering. I mean, come on, it takes a nuke to do this. So at the same time this gets knocked down, there's a lever here, a seesaw-type lever. That was one of the principles. You have to use all these mechanical planes and levers and stuff like that. So I think I used 5 of them here. Anyway, that pushes this thing up, boing, and that ball, the heavy ball, knocks another ball in this trajectory here. Now I've got my inclined plane, but at the same time, this heavy ball is going to pull this table over. Lots of energy available, so I can design this. So I'm going to actually pull the table under where eventually the leader ball is going to go. So this ball then rolls down the inclined plane, lots of potential energy goes, and shoots on out here, hits another, another thing that pulls the bottle up, the table's there, it all drops down, and you're done. So that's my Rube Goldberg invention using nuclear reactor. Obviously, I would be dying to build this someday, but they are wise in the reactor department or the reactor operations area that they never actually let me touch the controls. So it is a pity, because I have so many fun experiments to do, but I suppose wisely for the indemnity of the university, it's probably a good thing. By the way, Dr. Lineberry is in the same position. I don't think we've ever let him touch reactor controls either. So, all right, we have 10 minutes left, but I'm going to tell you what your assignment is, and what I want is to maybe just, normally I would do this in class, but since we're almost out of time here through all the introductions and so forth, what I would like you to do by next class, thank you, is on the contemporary issues side, just don't do any research on this. I want you to do it just off the top of your head. It can be handwritten, because normally I said I would do this, have you do it in class. But I would like you to list in your own mind what the 3 advantages of nuclear power are. And, you know, being able to put a liter bottle on a table would not be one of them. List the 3 disadvantages of nuclear power, because anybody who's rational about this field realizes there are some disadvantages as well as advantages. Nothing is a panacea. I'd like you to rank the following energy sources in terms of your feeling about them, their goodness, their badness. You know, you don't have to say, whoops. Oh, you do have to say why you picked one. All right, solar, wind, biofuels, fossil fuel, meaning primarily coal or oil, or nuclear. And then rank them in order of good to worse. And why did you pick number 1? And why did you pick number 2? By that I mean the second leading, not the last. Okay? So that for next time. Like I said, I don't want you to spend more than 10 minutes on it, because that's normally what I would do in class.
Dr. Ammo?
Yeah.
Do you want to define further the ranking, or do you want the students to do that? In other words, when you ask them to rank the power sources as best to worst, or best to not as good, best in what way? Do you want them to define the criteria?
Absolutely. Absolutely. I want them to think about what the criteria are, because it's a good leading question. You know, there are many, many ways to rank something, and you all have reasons that could be emotional, or they could be completely scientific in terms of capital costs or whatever. So, yeah, I would like you to pick out why you rank them. We're not going to get into, you know, the economics of nuclear power in this Engineering 120. We'll just be touching over them briefly. But I'll give you a little hint. This is something I want you to do extemporaneously, but at the end of the course, at the end of the 3 weeks, I'm going to ask you to repeat the same sort of thing in terms of, has your attitude changed about anything, or do you still have the same beliefs you came in with? So that's your little tiny assignment. What I'm going to do, oh yeah, the other thing, and all kinds of stuff for this course. I was going to have you design, as part of a homework, a fun design a nuclear reactor to heat your house. Okay? Just a minor little detail of a small nuclear reactor in your basement. Lots of room in your basement. Well, not everybody's basement, but hey, look, you can put it in a submarine, why not in a basement? But then I happened to be looking at I got this email, and by darn if the Toshiba company hasn't beaten me to it. And I got really grumpy about that. They apparently say, here, you can read that. You could soon have your own personal nuclear reactor in your basement, next to the hot water heater, conveniently located, or your washer and dryer. And the Toshiba 4-5 personal reactor, which is advertised as super safe, small, and simple. And the idea of this is quite simple. You just put your local reactor vessel down in your basement, and you have a little heat exchanger, and then you go into a, you know, a loop, electricity generation, everything. The 4-S, I guess it is, can run for 30 years without any refueling. Great. This is all true. It can. Doesn't need control rods. Great. So you can't use it as a Rube Goldberg machine. Anyway, just more proof that nuclear power is our future. When I was a graduate student, when I was still working in plasma physics and had nothing to do with nuclear engineering so much, I was a member of the American Nuclear Society. And at that time, the Canadians were advertising this cute little reactor they called Slowpoke. I don't know if they still make Slowpoke or not, if they still market it. But it was advertised as this super safe, super simple reactor that you could almost have in your basement. And I thought, that's a great idea. And so I had this dream ever since of having a small nuclear reactor in my basement. Well, I don't have that, but I do have it in the engineering basement. It's not my home, but I can sleep there. So enough facetiousness. We're out of time. I think you'll find that any and all of us can easily talk for 50 minutes without any problem at all. So next time, what we'll do is we'll talk about your contemporary issues assignment. We'll have a little bit of history. I'll talk a little bit about history and basically the physics of radiation, what radiation is, and so forth. And then we'll follow with some other lectures. So, see you Wednesday morning.